parametric equations. X equals this, y equals this. Okay, show that dy by dx. I've got to differentiate. Find dy by dx. That will be dy by dt divided by dx by dt. So differentiate y. So differentiate cos 2t. That will give us minus sine 2t. But I also have to differentiate the 2t to get minus 2 sine t. Plus differentiate sine t, I get cos t, so that'll be 2 cos t, and that's all over differentiate x, 2 sine t, and that will give us 2 cos t, just what I've just done. Right, I need to simplify this a bit. 2 sine, well, I know what sine 2t is, so that will be the same as minus 2 times, and then sine t is 2 sine t cos t plus 2 cos t all over 2 cos t. I'm going across the page here to try and save some space. Minus 2 times that, I'll be this minus 4 cos t. That cos t will cancel out with those. So divide on one of my cos t. Minus 4 sine t plus 2 all over 2, which equals, I'll put it the other way around, 1 minus 2 sine t. So I've differentiated it, I've got what they wanted, and now I've got to find the stationary values. So for stationary values, we have that 1 minus 2 sine t equals 0, so 2 sine t equals 1, so sine t equals a half, so t equals pi by 6. And we've got the coordinates, so I know what t is, and now I just need to find the coordinates. I need to know the x value and the y value, so that x equals 2 sine pi by 6, which equals 1, and the y value equals cos of pi by 3 plus 2 sine pi by 6, which equals a half plus 1, which equals 1.5. So stationary point is 1.5 or 1.5. Part 2, find the Cartesian equation. Well, that means I can't have any t's in there. So you could put sine t equals x over 2. So t equals sine to minus 1 x over 2. That's going to go horrible, so I'm not going to go that way. But if I get sine t equals x over 2, then I can use on the right hand side, like the cos one, cos 2t plus 2 sine t. I can expand this, and I know if I expand that, I get cos 2t equals cos squared minus sine squared, or I can turn that into 1 minus 2 sine squared. So I get y equals 1 minus 2 sine squared t plus 2 sine t. Cos 2t equals that bit. I know that sine t is x over 2, so I get y equals 1 minus 2 times that bit squared, so that'll be x squared over 4 plus 2 lots of sine t, which is x over 2. And that equals, I've got minus, that'll be a half x squared minus half x squared plus x plus 1. And that's what my equation actually is. Y equals that. Again, I'm a bit squashed here. I've narrowed a bit. Part 3 is like so. State the set of values that x can take. Well, we know that x is 2 sine t, and we know that minus 1 is less than or equal to sine t, which is less than or equal to 1. So if I double that, minus 2 is less than or equal to 2 sine t, which is less than or equal to 2, and that's x. That was saying it's x, so therefore that's my thing. Minus 2 must be less than or equal to x, which is less than or equal to 2. And now I can draw it, because all I have to do is draw y equals this bit to see where we are, but we can only go between from -2 to 2. And I know that 1 and 1.5, that 1.5 is a stationary value. And so my curve is going to go up here, down there. You could plot various points, but you mustn't go beyond those two. And that is 7 done.